क्या आवाज आ रही है माधुर?
हाँ, आपकी आवाज आ रही है। सबके सामने खाली जैन साहब का भी फोटो चला गया, जीसी जैन साहब का।
YouTube is live.
हाँ, YouTube इज लाइव सर। चलो देख लेना।
Meeting is live now,
Yes,
streaming live on YouTube.
Yes, sir. It is live, sir.
लाइव ऑन यूट्यूब हो गया हमारे। ओके, गुड।
Okay, sir. I'll admit everyone.
हाँ, अभी एडमिट कर दो, फिर शुरू करेंगे, टाइम हो रहा है।
Okay, we'll start the meeting.
सबको एडमिट कर लो।
Shobha Patki and Anil this side.
Good evening, sir.
Good. Hello.
Hi, Prabhat.
Hi.
गुड इवनिंग सर।
Dhawan Pune. Rashtrani is there. Good.
हाँ मेहता जी।
और इनमें से कोई भी मैं अपनी पढ़ाती
हाय
मेरा टैब है भाई, तुम्हारा फोटो दिखानी तुम्हारी, बोलो वीडियो
हेलो।
The speaker, unmute yourself. Speaker,
Hello.
unmute yourself.
Hello. Hello. See, I am having difficulty.
Only the
इसमें
speaker,
दिखा
unmute
रहा-
yourself.
Hello.
बोलिए सर, जैन साहब।
नहीं, ये दिखा रहा है मेरे इधर के भाई कैपेसिटी हैज रीच्ड एंड यू लीव द मीटिंग। ये कुछ प्रॉब्लम है इधर मेरे उसमें।
आपके इसमें नहीं, आपके इसमें कोई प्रॉब्लम नहीं है।
हाँ। So I will join from this mobile only.
ओके,
Should I join from the mobile?
No, no, you are there already.
No, sir, you are audible.
आपकी फोटो भी आ रही है सर, आवाज भी साफ आ रही है।
You do not leave. You do not leave.
Don't leave.
You have very good picture and personality also, sir.
नहीं, इसमें जो है ये दिखा रहा है कि capacity has been reached, so you cannot be admitted.
नहीं, you are already admitted on one device.
नहीं, बट मेरे को दिखना तो चाहिए ना। हाँ, मेरा इसमें है एडमिटेड।
But I am seeing you, sir.
नहीं, किसमें देख रहे हैं आप? लैपटॉप से कि मोबाइल से?
मैं लैपटॉप में देख रहा हूँ। You are available, sir.
लेकिन मेरा प्रॉब्लम ये हो रहा है, मेरे को नहीं दिख रहा है।
वो साइड कॉर्नर में जाता होगा आपका फोटो। आप थोड़ा वो ये सबके व्यू, गैलरी व्यू लीजिए। गैलरी व्यू पे क्लिक करोगे तो मिल जाएगा शायद आपको। Now, because so many persons are waiting list, they have to go to YouTube probably.
I think you should inform that they should log on to the YouTube. Okay, they should switch to YouTube. Please inform.
हाँ, अक्षय वो इन्फॉर्म कर दो।
Akshay will inform, sir.
Okay, good. अरे 7:07 हो गए।
हाँ,
देखो टाइम पे करो।
ये सर शुरू करते हैं सर।
अरे भाई, मेरा जो है नहीं हो रहा है।
जैन साहब, आपकी फोटो आ रही है और आवाज भी आ रही है। अब हम शुरू कर रहे हैं, आप मोबाइल से जुड़ जाइए। फिर
जिस डिवाइस प्लीज गो अहेड। नाउ
Okay, so if you are seeing me, then I will do my job.
हाँ,
Yes,
हमें
sir.
दिखाई दे रहे हैं आप, बहुत अच्छे, आवाज भी आ रही है साहब। चलिए शुरू करते हैं सर।
Yes, we are hearing you.
ओके, अक्षय मेरी आवाज आ रही है ना?
हाँ सर, आ रही है।
ओके, विल स्टार्ट।
Now you can unmute other participant except that
यस,
host person.
ओके। All are requested to please
Good evening, sir.
mute their mics. Good evening, namaskar. As you all know, we are here today to pay tribute to Dr. Vikram Sarabhai, who is known as father of India's space program. Today is birthday, and year 2019 to 20, it was celebrated as his birth centenary year. And last year in the month of August, ISRO had a program in Ahmedabad by Department of Atomic Energy and Department of Space. And throughout the year, ISRO has arranged a number of programs all over the country. So on behalf of Indian space industry, industry exhibitors, Ahmedabad and Gyan Shiksha Trust, Ahmedabad, I welcome Padam Shri Professor Pramod Kale, ex-Director Space Application Center, and Vikram Sarabhai Space Center, Trivandrum. Then Shri G.C. Jain, who is the Chairman of Gyan Shiksha Trust, and Shri V.K. Jain, Chairman Broadcasting Engineers Society, Ahmedabad Chapter, Shri Anand Pathak, President Space Society of Mechanical Engineers, Shri Ashish Soni, Secretary of Space Society of Mechanical Engineers, and Shri Sanjay Saxena, who is our media partner and Chief of Sunrise India Samachar, New Delhi, and you all who are joined online through Zoom and YouTube channel. As you all know, today is a festival day. In addition to Janmashtami, we have National Remote Sensing Day and the birthday of Dr. Vikram Sarabhai. Now, lots of programs have been organized by ISRO-based professional societies all over the country. Shri Kale had a very busy schedule since morning. In spite of all that, he accepted our invitation and spared time from his tight schedule to deliver a popular talk on Dr. Sarabhai's birthday. He has worked very closely with Dr. Sarabhai and Dr. Satish Dhawan, who practically worked for so many years to give shape to Dr. Sarabhai's vision. Today is our first experience for online broadcasting on YouTube through Zoom channel. Let us hope that we don't face any technical issue during the Professor's Kale's talk. I request all to close their mics and ask questions, if any, at the end of the session. You can post your questions in the chat box. So later on, we'll take up from chat box and answer. So once again, I welcome all of you. I request now Mr. V.K. Jain to brief us about Dr. Vikram Sarabhai. Mr. V.K. Jain, please.
Now I am audible, sir?
Yes.
Okay. So, respected Professor Padam Shri P.P. Kale Sahab, current Director, ICIT Private Limited, Pune, ex-Director, Space Application Center, ISRO, Ahmedabad, and Vikram Sarabhai Center, ISRO, Trivandrum. Shri G.C. Jain Sahab, Chairman, Managing Director, MCBS, ex-prominent scientist from Space Application Center, ISRO, and expert in the broadcasting, SATCOM, video, and studio technology. Shri A.S. Mathur Sahab, MD, ISIE, ex-Group Director of ISRO Space Application Center. Shri Ashish Soni, Senior Scientist from SAC ISRO, SSME member. Online Galaxy of the Scientists Engineers from ISRO, Broadcast Engineers Society, Space Society of Mechanical Engineers, IET, Institute of Electronics and Telecommunication Engineers, organizing team members from MCBS, Indian Space Industry Exhibitors, Gyan Shiksha Trust India, course participant of the lecture series on satellite communication and its application for the common man, students, faculty from institutions, and other distinguished participants. Very good evening. namaste to all. I warmly welcome you in August gathering of centenary of year for 101 birthday of celebration of prominent space scientist, visionary, motivator, father of Indian space program, Dr. Vikram Sarabhai. I thank organizer Shri A.C. Mathur, Indian Space Industry Exhibitors, Indian, and Shri G.C. Jain, CMD Gyan Shiksha Trust for providing the platform to speak about Dr. Vikram Sarabhai. It's my great privilege and feel proud to work on to some extent towards his vision while contributing the 36 years service in ISRO Space Application Center for realizing to his very mild extent. Dr. Vikram Sarabhai was born on 12th August 1919 in his illustrious family and well known for its social prominence and wealth in business and philanthropy. His parents were professionally prominent, and his father, Ambabhai Sarabhai, is being a pioneer in textile industry, and his mother, Sarla Devi, being a social activist. He passed his intermediate examinations in science subject from Gujarat College in Ahmedabad, and then for further studies, he went to England. He was an intelligent student, and from his childhood, he had an interest in science. In England, 1940, he took his admission in St. John's College, University of Cambridge, and pursued tripos in natural science. In 1942, he published his first scientific paper, Time Distribution of Cosmic Rays. In 1945, he came back to Cambridge for further research on cosmic rays and earned his PhD degree from his thesis, Cosmic Ray Investigation in Tropical Latitudes. In 1947, he came back to India and then joined Indian Institute of Science in Bangalore to carry out research on cosmic rays. Nobel laureate Professor C.V. Raman advised him to do research. Shalini Sarabhai and had two children, Mallika and Kartikeya Sarabhai. Dr. Vikram Ambalal Sarabhai was an Indian physicist and astronomer who initiated space research and helped to develop nuclear power in India. He was also chairman of Atomic Energy Commission. The most significant contribution of Dr. Vikram Sarabhai is in establishing the Indian Space Research Organization, ISRO, in 1969. The objective behind of Soviet Union and USA being orbited around the Earth was getting ready for the new era of space exploration. The Indian National Committee for Space Research in COSPAR was set up by the government with its headquarters at the Physical Research Laboratory and Sarabhai being its first chairman. The first contours of Indian space endeavor were drawn up at this time through the meetings of INCOSPAR under the visionary leadership of Sarabhai. One of the first tasks was to set up the rocket launching station at Thumba, close to geometric magnetic equator. The first rocket from TERLS was launched on 21st November 1963. Sarabhai also initiated establishing Space Science and Technology Center SSTC in the outskirts of Trivandrum, known as Vikram Sarabhai Space Center. Major work of Vikram Sarabhai is to establish ISRO and contributed immensely in the field of science. Eventually, ISRO became the largest government space agency in the world. Some of the institutions established by Dr. Vikram Sarabhai are Physical Research Laboratory in Ahmedabad, Indian Institute of Management, Ahmedabad, Community Science Center, Darpan Academy of Performance Art, Ahmedabad, along with his wife, Vikram Sarabhai Space Center, Trivandrum, Space Application Center, Ahmedabad, Faster Breeder Test Reactor, Kalpakkam, Variable Energy Cyclotron Project, Calcutta, Electronic Corporation of India Limited, ECI, Hyderabad, Uranium Corporation of India Limited, Jadgura, Bihar. Dr. Sarabhai was no more, but as a result of Dr. Sarabhai is no more, but as a result of Dr. Sarabhai dialogue with NASA in 1966, the satellite instruction TV experiment site was launched during 75-76. He was on Padam Bhushan in 1966 and Padam Vibhushan in 1972 and Shanti Bhushan Swarup Bhatnagar Prize for Science and Technology in Physical Science for Indian Space Program. Internationally regarded as a father of Indian space, he left us in December 1971 at Thiruvananthapuram. His famous quote, "We must be second to none in the application of advanced technologies to the real problems of man and society," is always applicable for all scientific technical development of the universe. Now I have Shri Mathur to introduce Shri Kale Sahab before his popular talk, Space for Future. Thanks for paying attention. Shri Mathur Sahab, now you can take.
Thank you, Jai Sahab. I request Shri GC Jain to kindly introduce our chief guest, Padam Shri Pramod Kale Sahab.
Thank you very much. All our august audience, this is a great day to celebrate today. I take this opportunity to introduce to you Professor Pramod Kale. Pramod Kale is well known to everybody. He needs no introduction. However, for sake of formality, I have this opportunity to introduce him to you. Professor Pramod Kale was born on 4th March 1941 in Pune. He completed his college education from Fergusson College in 1958. He graduated from MS University, Baroda in 1960 and post-graduated from Gujarat University in 1962. Professor Pramod Kale has worked with Indian Space Research Organization for over 32 years and held several leadership positions. He started his work on satellite tracking as Physical Research Laboratory in 1960, and he was a member of the first team sent to Goddard Space Flight Center, NASA, USA, for training in launch of sounding rockets in 1963 and establishing the Tumba Equatorial Rocket Launching Station. He has worked as a research student with Dr. Vikram Sarabhai at PRL from 1962 to 65. Professor Pramod Kale held notable assignments and positions in ISRO. I will list some of these. He has been head of Electronics Division, Satellite Systems, Space Science and Technology Center at Thiruvananthapuram. Project Manager, Site Program at Space Application Center. Project Director, INSAT-1 Planning. Mission Director, ISRO Payload Scientific Missions. He has been Director of Space Application Center, ISRO, and also Director of Vikram Sarabhai Space Center, VSSC. He has been instrumental in establishing various national and international projects and programs in education, science communication, space science and technology in the country. He has been a trustee, president, and chairman of several prestigious bodies, organizations, namely Bharatiya Vidya Bhavan, Indian Institute of Education, Community Aid and Sponsorship Program, CASP, to support the children. He has several papers in national and international journals to his credit. He has authored a book, Color in Nature, 2011. He is currently Director of ICIT Private Limited in Pune. He is life member and fellow of several societies, professional organizations, and academic bodies. And some of these are Indian Society of Remote Sensing, Indian Society of Geomatics, Gujarat Science Academy, Maharashtra Science Academy, Institute of Electronics and Telecommunication Engineers, Computer Society of India, Astronautical Society of India, Vikram Sarabhai Memorial Trust, University Grant Commission, CMAS, Indian Institute of Education, Rajiv Gandhi Science and Technology Commission. He is recipient of several national and prestigious awards. Sri Hari Om Ashram Vikram Sarabhai Award 1975 and prestigious award Padam Shri 1984. R.L. Badhwa Gold Medal IET 1990. Bharat Jyoti Award for National Papers Program Progress 1999. Microwave Pioneer Award 2014. Jeevan Sadhana Gaurav Award 2016 from Savitri Bai Phule, Pune University. Pune's Pride Award for Excellence in Academics. Now we will request Professor Kale to give his popular talk, Space Our Future. Thank you very much.
Thank you, Sri Jain, for this introduction. Before I begin, let me start by saying that I had the good fortune of having been able to work with Dr. Vikram Sarabhai and also Professor Dhawan. And today, 101st birthday for Dr. Vikram Sarabhai, and next month it will be the centenary year start for Professor Satish Dhawan. He was born on 25th September 1920. I'll be talking about our whole program, what has happened so far, and what future lies in front of us. Okay, Mr. Mathur, is the PowerPoint presentation ready?
Yes, sir.
Okay.
I will share the presentation, sir.
Okay, then you should start. You can share
on the screen.
Okay. I'll be talking about space and why we consider space to be our future, because it is very important for us to note as to what has happened so far. Next slide, please. Charles Kettering had said, "My interest is in the future because I'm going to spend the rest of my life there." And we should be all concerned about future, not just our own future, but also the future of mankind. Next, please. George Santana had said that those who cannot remember the past are condemned to repeat it. And when we think about the future, we should not forget the past. We need to appreciate and understand history and build upon the knowledge that has been gained from the past. Next, please. We have a very vibrant, mature, and ambitious space program today. It had started as a space research program that was soon driven by the applications of the space technology. And we should not forget our history. Next, please. When we start thinking about our program, we should also think about how did we all get there? The Physical Research Laboratory, or PRL, was established by Dr. Vikram Sarabhai at Ahmedabad in 1948. Dr. K.R. Ramanathan had joined with him there as the first director of the laboratory, and both Dr. Ramanathan and Dr. Sarabhai had worked with Sir C.V. Raman. Now, research in cosmic rays and effects of solar activity on the upper atmosphere were the main thrust areas in Ahmedabad under the leadership of Dr. Ramanathan and Dr. Sarabhai. Dr. Ramanathan had retired at that time as the Deputy Director General of the Indian Meteorological Department. Sarabhai was a much younger person compared to Dr. Ramanathan. And if one were to actually look through the old books, we will find that in the book on the Raman effect by S. Bhagwantam, he has given the full credit to Dr. Ramanathan, that Ramanathan was the first person to have actually seen the kind of a change in the wavelength that was happening. It is Raman who gave the complete explanation for that particular effect, and then it started getting to be known as the Raman effect. Next, please. The year 1957 was declared as the International Geophysical Year, IGY. In that year, the solar activity was expected to reach the maximum in that particular solar cycle. A large number of institutions in India and abroad were expected to collaborate and cooperate in carrying out research work concerning the effects of the solar activity on the Earth's atmosphere and environment. PRL, the National Physical Laboratory, NPL in Delhi, Tata Institute of Fundamental Research were the leading institutions working in the IGY period, and many universities in India were also involved in the work. The IGY was extended to 1958 also and was followed up by the International Quiet Sun Year, IQSY, in 1964. Next, please. Next slide. You need to change the slide.
Yeah, I'm trying.
More than 60 years ago, first satellites made by human beings were launched successfully in the orbit of the Earth. The first satellite was the Sputnik 1, launched by USSR on 4th October 1957, and the second satellite was the Explorer 1, launched by USA on January 31st in 1958, and the space era had begun then. I was a student in Pune at that time when these satellites were launched, and I had definitely decided that space would be the subject that I would be studying in the future. I have had close to 60 years of association with our space program since the time I joined PRL in 1960. And I am still studying space science, technology, and its applications in our day-to-day life. Next, please. These were the first two satellites. On the left-hand side, you see the Sputnik 1, and the next one is the Explorer 1. If you see these particular satellites today, we start wondering as to how they were able to actually generate power. They had only the batteries. They had no solar cells in those days of 1957, 1958. And so once the batteries were consumed, then the satellites stopped functioning. Next. Today is the birthday of Dr. Vikram Sarabhai. He was born on August 12, 1919, and he passed away on December 30th, 1971. Next, please. Recognizing the importance of space research in our country, in February 1962, the Indian National Committee for Space Research in COSPAR was established with Dr. Vikram Sarabhai as the chairman of the committee. It was decided that we should establish a rocket launching station near the geomagnetic equator. The work was immediately started and a team was formed at the Physical Research Laboratory at Ahmedabad to be sent to USA in January 1963 for training in sounding rockets. I was fortunate to be in that first team, and our first sounding rocket was launched on 21st November 1963. Next one. That is myself and Mr. Prakash Rao at the Goddard Space Flight Center in NASA, USA in 1963. Next. And this our first team that we had was Mr. B. Ramakrishna Rao, Mr. Prakash Rao, myself, Mr. Arvabudan, and Mr. H.G.S. Murthy. Now, the first four of us, we were all electronics people. Mr. Murthy had come from the defense production factory. Next. And then Mr. APJ Abdul Kalam and Ishwar Das, these two people joined in the next 2 months. Kalam was the only person with aeronautics background. Ishwar Das came from the central workshop of our atomic energy. So Kalam was the only one who had some flight related experience and knowledge about various things. Next, please. These are the Nike Apache rockets. The rockets came from USA. And for our first experiment, the payload had come from France. The project scientist for that was Professor Blamont from France, CNES, and Professor P.D. Bhavsar from Physical Research Laboratory. And we were able to successfully launch this particular rocket on November 21st, 1963. Next one, please. As you can see here in this photograph, the church, there is a building, and that was the only one, what should I say, Pakka or stone building at the Tumba Equatorial Rocket Launching Station, the village, Palitura or Tumba, where we had started this work. We had to take special permission from the bishop there to actually get this particular church vacated and then being able to use that particular church. And that was the only place where we could assemble our rocket in those days. Next, please. Here you can see Dr. Vikram Sarabhai, Professor Satya Prakash, Professor P.D. Bhavsar, and Dr. Upendra Desai discussing as to what we should be doing the next, what experiments were to be planned. Next, please. When I went to Thiruvananthapuram at that time, one of the things that I found out was that the place was such a huge place and we had only one vehicle. And I started hiring a bicycle from a next nearby village. And then that became a kind of a regular thing in our Tumba Equatorial Rocket Launching Station, that whenever I used to visit there, they would hire a bicycle for me. Once I reached there for the job after in 1966, then even a cycle was purchased for me to by the office there. We used to carry most of the parts as required on the bicycle, so that was the only easy available vehicle for all of us. Next. After the Nike Apache rocket, then we had the Bélier Centaur rocket, and initially few rockets came from France, but then we started manufacturing these particular rockets in our rocket propellant plant for the propellant, and the rocket shells were being made at the central workshop in Mumbai of atomic energy, and later on at our own workshop. Next, please. I was working on the rocket at that particular time. This particular is the nose cone of the Bélier Centaur rocket. Next. I hope some of you can recognize the person who is sitting on the right-hand side of the screen, left-hand side of the screen for you. That's Kalam. When Kalam and Arvamudan, they were assembling the payload at that time. Next, please. That's Professor Blamont and Dr. Vikram Sarabhai discussing about one particular experiment which was to be carried out. Next. Dr. Bhabha used to visit also turtles quite often, and this particular photograph is the one that actually reflects the way he chose with Dr. Vikram Sarabhai the location for our Space Science and Technology Center at the top of the hill or the Valley Hill there. Next, please. It's Dr. Sarabhai, Kalam. Kalam was explaining at that time how we were going to do the spiral welding as well as filament winding for these our rockets. Next one. That's our first indigenous rocket, the Rohini 75. This is a 75 millimeter diameter rocket. Dr. Vaijay Rao, you can see there, explaining the situation to Dr. Vikram Sarabhai. We were able to launch this one in 1967. Next. Dr. Sarabhai had also thought about as to what we should be doing in terms of the space applications, particularly the space communications. And one of the idea was to actually establish the experimental satellite communication Earth station, and that station is still active and fully operational. That's at Ahmedabad, and today our Space Application Center headquarters or Space Application Center is right there itself. Next. This is that SKS or the Experimental Satellite Communication Earth Station. Now, this was the first station. It's 14 meters in diameter antenna, and this was imported from Japan. This had been our main place where education and the training regarding satellite communications was imparted. This became the main station for our satellite instructional television experiment also. The knowledge that we gained while establishing this particular station became fully useful for us when we decided that we are going to indigenously make our own operational station also. Next. In 1966 to 1968, the work was going on at a very fast pace at the Thumba Equatorial Rocket Launching Station, and then it was decided that the Thumba Equatorial Rocket Launching Station would be dedicated to the United Nations. And with the dedication to the United Nations, it would then be possible for any other country to bring their equipment, to bring their experiments and carry out the experiments at the Thumba Equatorial Rocket Launching Station. And this was a major event that took place on 2nd February 1968. We had a total of 4 different rockets that we launched on that particular day. And I was involved in 3 of them. This is there, Dr. Vikram Sarabhai, Indira Gandhi, they are watching the rocket takeoff in the afternoon. This is Indira Gandhi as the Prime Minister. She initiated another rocket launch later in the evening. This is the second time I had seen Professor Satish Dhawan in Thumba Equatorial Rocket Launching Station. First time was in 1965, and second time was on this 2nd February 1968 when he was visiting there. In the evening, Dr. Vikram Sarabhai gave his speech, and later on, Mrs. Gandhi, Indira Gandhi, as the Prime Minister, she also gave the speech dedicating the station to the United Nations. And this is what Dr. Sarabhai had said in that particular lecture. There are some who question the relevance of space activities in a developing nation. To us, there is no ambiguity of purpose. We do not have the fantasy of competing with the economically advanced nations in exploration of the moon or planets or manned spaceflight. But we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the applications of advanced technologies to the real problems of man and society. We were inspired by him, and based on that, we had started our work. Today, we have achieved most of the goals set out by him, and we are looking forward to contribute in many areas. 2 years ago, on February 2nd, 2018, I had gone to the Thumba Equatorial Rocket Launching Station to commemorate the 50th anniversary of that particular day. And here we are watching a rocket taking off on that day. Next to me on my right-hand side is Mr. Shivan, the chairman of ISRO. We started, next slide, please. Next slide.
Yes, sir. There is a hold. I am trying to change it. It is not changing. Varun? Light changing.
Screen is frozen for me.
Yeah, it is frozen. I am trying.
Okay. Next,
Oh, yeah.
please. Yeah. It changed. Okay. Next one.
Yes, sir. This is okay?
Yeah, this is okay. Next slide now.
Okay.
This is what I was explaining, that this is the second time that I was seeing Professor Satish Dhawan. First time I had met him was in 1965, and then he had come for this particular ceremony. Next. This is the time when Mrs. Gandhi gave the lecture dedicating the Mumbai Equatorial Rocket Launching Station to the United Nations. Next. This is what Dr. Vikram Sarabhai said, which I had read earlier. Next one. 2 years ago, on 2nd February, we launched another rocket and had gone to Mumbai Equatorial Rocket Launching Station for that. Next one. After the first Rohini 75 rocket, then we started making larger and larger rocket. And this is another rocket that we were making at that time. Next one. Next slide, please. Dr. Vikram Sarabhai, you can see here with Professor Chitnis, Mr. Thakur. This occasion was a small piece of the moon rock was brought, and that particular moon rock people were examining in, I think this was in Ahmedabad as far as I remember. Next, please. We had started many of the studies regarding the Indian National Satellite for television, telecommunications, meteorology, radio broadcasting. And after completion of the study with MIT, Dr. Vikram Sarabhai had visited there. And at that time, I was the co-chairman for that particular study. And I think this is the last photograph that I know of myself with Dr. Vikram Sarabhai. Next slide, please. In 1969, the government had decided that to go ahead with the satellite communications operationally in India. They were thinking about importing this ground station, and that after learning about it, Dr. Vikram Sarabhai had taken a decision, and he met Sardar Soren Singh. He was the Minister for Communications at that time, saying that we are in a position to actually make this kind of a station ourselves. The first one we had imported, the next one we should not. Everybody later on agreed with Dr. Sarabhai, and this was the station that was made. New Standard Engineering, Electronics Corporation, and everybody joined with it. Atomic Energy took the lead. The Wing Commander Rao, Colonel Pant, with this Commander Kohli, all those people, they worked on this. And this station that was delivered on time is the Intelsat Standard A station with 27 meters in diameter, kind of a large antenna. First such antenna being made in India. We made two such antennas at that time, one for this RV station near Pune, and the other one was for Dehradun, which became later on operational. And this station, which became operational in 1970, is still operational today also. Next one, please. Dr. Sarabhai had communicated his vision for the development of the space technology and its applications in many papers and the decade profile for atomic energy and space. After he had passed away, every 10 years a profile for the next decade had been issued by ISRO. This has resulted in excellent participation by the academic institutions as well as industries in realizing his vision in a self-reliant way. Next one, please. What has Dr. Sarabhai left behind? Establishment of PRL, TERLS, Experimental Satellite Communication Earth Station, the Rocket Propellant Plant, Space Science and Technology Center, and Sriharikota Range. During his time, the start of the SLV-3 project had taken place. He established the Indian Space Research Organization, starting with as a committee, but then later on it became as a full-fledged organization. The conceptual development of the satellite instructional television experiment and the Indian National Satellite projects were taken up during that time. The delivery of the indigenous operational Intelsat Standard A station at RV and start of the remote sensing program and a visionary decade profile for atomic energy and space was issued by him. He was of the opinion that there was no specific point in a 5-year plan when we took more than 7 years to complete a specific project, either for the atomic energy or for the space. And so what was decided by him was that we will issue a decade profile and it should be available to the industry, it should be available to the parliament, it should be available to all the working people so that they know exactly what we were going to do in the future. Next one, please. Next slide. After Dr. Sarabhai passed away, interim period, Professor M.G.K. Menon became the chairman, and at that time they had decided to have Professor Satish Dhawan as the chairman, but he had already committed to be at Caltech. So he said that after he finishes that his assignment, then he would come, and he came back in 1972 June or so, and he took over as the chairman of the Space Commission and secretary to Government of India, particularly in charge of the Department of Space. Professor Satish Dhawan was the director of the Indian Institute of Education in Bangalore, and he had decided that he will not leave that particular position, and the Prime Minister had accepted that, and the Prime Minister had also accepted that the Department of Space at ISRO, its headquarters will be moved to Bangalore at that time. Next one, please. During the time of Dr. Vikram Sarabhai, he had thought about the satellite instructional television experiment. What you see here is the ATS-F satellite, and I was fortunate to have worked on this particular satellite. The satellite was very, very large satellite. The antenna that you see on the top of that one itself is about 9 meters or 30 feet in diameter. And the idea was that such a large antenna, large satellite to be put in the geostationary orbit, if we could do it, then we could receive the signals on a small ground station made at low cost. The next one, please. And the idea was that, okay, using a low cost 10 feet diameter or 3.5 meter diameter antenna, we can actually receive the signals and show them on television. Now, this was our idea for the satellite instructional television experiment, and we successfully were able to carry out this experiment in 1975 to 1976. And this was the first time television signals all across India were really available from one location. Next one, please. This was that antenna which could be carried or which had to be established into various villages. And we put these kinds of antennas in about 2,200 villages or so in various states like Rajasthan, Madhya Pradesh, Bihar, Orissa, Karnataka, and Andhra Pradesh. Next one. This is a television program in progress. For the first time, people were able to actually watch this kind of television program. In the morning, we had the educational television. In the afternoon, in the evening, we had the general as well as for the agriculture-related things, instructional television program. Next one, please. During this satellite instructional television experiment, Professor Dhawan had visited us there, and with him right now we see is the Mr. Vidyacharan Shukla. He was the Minister for Information and Broadcasting, and I was in charge of the television and electronics hardware for this particular satellite instructional television experiment. Next one. I think this is a later time period. Professor Yashpal is the director of the Space Application Center, and Professor Chitnis, who became later on director of the Space Application Center. And what you see in the background is our SKS antenna. Next one, please. Next set. Yeah. We see here Professor Satish Dhawan, Professor U.R. Rao, Kasturi Rangan, inspecting the harness for the Aryabhatta satellite. This was in Bangalore. Next one. Professor Dhawan in the clean room looking at the hardware for the Aryabhatta satellite. We see here Professor Rao as well as V.A. Thomas. That's our first, next one. Next slide. Yes, that's our first Aryabhatta satellite. And the next one is the Bhaskara satellite. Bhaskara satellite was the first satellite which was actually had some instruments for the remote sensing. And Aryabhatta was a scientific satellite, but Bhaskara 1 had the first time we put, as you can see here, the microwave horn also on this particular satellite. Next one. So now Professor Dhawan, Dr. Brahma Prakash, Srinivasan and Kalam discussing here regarding the SLV-3 rocket. Next one, please. So Srinivasan, Professor Dhawan and Kalam discussing regarding the interstage for the SLV-3 rocket. Next one. This is a fully assembled SLV-3 launch vehicle on its trailer being carried for the launch with Professor Satish Dhawan. I think we can see Jayamani and we can see Kalam. Next one, please. The inspection of the rocket with Kalam, Professor Dhawan, Srinivasan and Colonel Pant. Next one, please. That's our first Rohini technological payload, or the RTP as we used to call it. This idea was that with this particular small rocket, we were able to launch a 40-kilogram satellite in orbit. The first one became unsuccessful, but the second flight became fully successful. Next one, please. That's the SLV-3 liftoff from the Sriharipota Island. Next one, please. We can see here Colonel Pant, Professor Dhawan, Kalam, Dr. Manmohan Singh. At that time, he was the member finance for the Space Commission. Professor M.G.K. Menon, Mr. Jayamani, Sri Narayana, discussing about the SLV-3 related things. And that's after. Next one, after the successful launch. Next slide, please. This is after the successful launch of the SLV-3 with Kalam and Professor Dhawan. Extending to next one. To the Prime Minister as to what has happened and what comes next. Next slide, please. So, Professor Dhawan visiting the Vikram Sarabhai Space Center, particularly looking at the components which are being made of the fiberglass. You can see here Radhakrishnan, who later on became chairman, ISRO. Next one, please. In this slide, we can see here now Dr. Gowarikar explaining what was happening with the fiberglass related things with Mr. C.R. Satya also being there. The photograph of the person that from rear that we saw taking or walking next to the bicycle, that's Mr. C.R. Satya next to the right-hand side of Professor Dhawan. Next one. We had a very interesting opportunity that became available. That was the third experimental flight, or the third flight of the Ariane launch vehicle. And with this, in this flight, we were able to have the Ariane passenger payload, Apple, as what we call, and that's our first communication satellite that was built in India. And we used the fourth stage of the SLV-3 as the final rocket motor for the Apple satellite. This was the first communication satellite that we built. Next one. Here is a satellite being carried through a bullock cart, but the idea here was that we needed a vehicle which had the least amount of metal in it, and therefore this was the vehicle that was used for carrying the satellite during its antenna test. Next one, please. That's the InSat-1 satellite. For this satellite, I was the project director. The studies I had carried out from 1969 onwards. Finally, we were able to launch the first satellite in 1982. That satellite became unsuccessful, but the next one, next slide, please. This is the InSat master control facility that we built at Hassan. That's about 180 kilometers away from Bangalore. At that time, we had only 2 antennas, as you can see here. Today, there are more than about 13, 14 such antennas in that place, because we are controlling about 14 satellites from that particular facility now. The one that we built in 1978-79 today is controlling more than 13 to 14 satellites. Next one. This is the InSat 1B satellite. After the first one became a failure, the second one was getting ready. And that satellite, next one please, we had to launch using the Space Shuttle Challenger. And this particular, our requirement was that it should be a nighttime launch, because we wanted a specific angle between the Earth, Sun, and the satellite. Next one. And that's the InSat 1B satellite being taken away or taken out from the orbiter or the Challenger orbiter. Next one. This satellite became fully successful, and it was dedicated to the nation by the Prime Minister Indira Gandhi at that time. And when she had visited there, Professor Dhawan was there, Professor Rao was there, and she was visiting the whole station at that time. This happened in 1984, February. Next one, please. That's Professor Satish Dhawan with Professor Rao. Next one, please. You can see here Professor Menon, Professor Satish Dhawan, Dr. Ram Seshan. Ram Seshan became the director of the Indian Institute of Science after Professor Dhawan retired as the director. Next one, please. Next one, please. Professor Satish Dhawan retired in 1984 September, and he left behind the successful completion of the SLV-3 Satellite Instructional Television Experiment, Satellite Telecommunication Experimental Project, STEP, Ariane Passenger Payload Experiment, InSat-1 Satellite, Aryabhatta, Bhaskara-1 and Bhaskara-2. During his time, the foundation was laid for our liquid propulsion systems. It was possible also for us to establish the National Remote Sensing Agency and establishment of the National Natural Resources Management System, and designs for the ASLV and PSLV were finalized during his tenure. Next one, please. These are some of the rockets which we made after the first rocket, that was the Nike Apache, which was imported. Later on, we started making our own rockets. Next one, please. So that's a Rohini Mark II 300 and Rohini 560. Next one. Those are the different types of rockets that we built from 1967 onwards, all the way to the large one like RH-560. Next one. That's the ASLV launch vehicle, and the launch vehicle taking off. The first 2 flights were failures, but later on they became really very interesting success. And from these particular rockets, we learned how to manage much larger rockets than ASLV. Next one. The first PSLV launch vehicle had become failure in 1993, and then I moved to Trivandrum in 1994, and we found out exactly what was the problem. And the PSLV D2, the second flight, liftoff took place in October of 1994. And that was the first successful flight, and after that, we have now launched more than 50 such rockets with only 2 failures so far, as I remember. Next one, please. After that came our PSLV, or the Polar Satellite Launch Vehicle, larger ones, and the GSLV Mark II. The PSLV we have been able to use also for launching our satellite towards the moon as well as towards the Mars. The GSLV has been used mainly for launching our large communication satellites. And the GSLV is the one that uses the cryogenic technology. Next one, please. This is the Earth station which had to build for the, as you can see, for the Chandrayaan. Again, there was a talk about importing such a station, but it was decided that we are going to make it. And then I was asked to go back as the chairman of the Critical Design Review Committee, and we did a full review of all the designs and made certain that yes, we can make it right here in our own country. That kind of a station which can be qualified for the deep space network. Next one. That's at the top of that particular station. Once it had completed, I had gone for the inspection of the station. Next one. That's the Chandrayaan-1 model. Next. That's a polar area image of the moon taken by Chandrayaan-1, because we were looking at the next one would be to actually go towards the polar area of the moon. And that's the one that we attempted on the Chandrayaan-2. Next. This is the Mars orbiter mission launch. Again, we use the PSLV C-25 or the 25th vehicle. Next one. During the launch for this particular launch vehicle, I had gone there, and one of my students, Mr. Hemil Modi, a student working with me, had also come with me. So this is just before the launch in the night. Next one. With the Mars orbiter mission, we demonstrated that yes, we can actually get to the situation, and after so many days, our systems will work. Our satellite was injected properly into the Mars orbit and took very good photographs. We were not able to actually complete the actual measurement of the methane which we were looking for. Maybe in the next one, we'll see what happens. Next one. That's a photograph of the Mars surface. Next. And a very detailed photograph of the Mars surface. Next one. Now, that's the launch for the Chandrayaan-2. Next. Next slide, please. Okay. This is the Chandrayaan-2 lander that we were looking for, and later on you will see in the next slide the actual thing which was supposed to have come out. This is the one that actually crashed instead of landing. Next one. We were expecting this small vehicle to actually move around on the moon, but I think now Chandrayaan-3 will be able to do it. Next one. We have carried out quite a large amount of research and operational space services like space communications, meteorology, remote sensing, navigation and position determination. Each one of them today has become so common that many times we take it for granted and we don't really pay enough attention as to what is going to happen. Next one. There are many interesting aspects of space technology and applications which are not so commonly discussed. And when I look at the future, this is what we should be thinking about and what we should be looking at. Next one. We started with the putting an observational camera or instrument on our communication satellite, but this was later on followed up with an actual operational meteorological satellite. And when we were just about ready to launch this satellite, at that time the the Columbia accident took place, Columbia orbiter, and in that one, Kalpana Chawla had perished. So this particular satellite was then named as Kalpana Meteorological Satellite. Next one. Now, you can see here the kind of a photograph that we take every half an hour or so. And if we can take multiple photographs, we can actually make animation out of it So we can see exactly how the clouds are moving. And this is the data which we had been using for our meteorological predictions. From 1982-83 onwards, every day more than 24 such pictures we take. If necessary, we can take every 5 minutes a picture, particularly when the cyclones are coming. Next one. This is the way we are actually using the data coming from our satellites, and we can actually track the satellites. Next one. That's the resource sat, which gives us far more detailed pictures compared to our Indian remote sensing satellites. And now this is the one that gives us a much more detailed images of the Earth. Next one. This is the Mumbai, as you can see, the Bandra Kurla complex block and Mithi River. One of the very interesting things that has happened is that the amount of data that we are generating using our satellites, this data is being utilized in about 19 or 20 different countries. They are participating in getting the data from our satellites, and we are earning fairly good quality, a fairly good amount of foreign exchange from that particular data that is being supplied to all the people. Our satellites, the remote sensing satellites, have proven that yes, we can do far better cameras compared to many other countries. Next one. We're using this data that we are generating, particularly for looking at the drought management assessment also. Next one. We're looking at it as to how we can find out where the underground water is. Next one. What happened in Mumbai, particularly when the fire took place in that Devanar, and how the smoke had actually spread all over. Next one. With the satellite instructional television experiment which we started, then we followed it up with the INSAT satellite. And today, most of all these television channels that you see, in those days, in a single transponder, we were able to put one single television channel, and that too in the initial period was black and white. Today, we can actually load more than 16 such channels on any of these satellite transponders. That's how we are able to see about 1,000 channels of television being available in our country today. Next one. What we started as a utilization of the system for the education, it was followed up with our system for the EduSat, satellite for the education. It was not utilized properly for the long enough time. So, but still, today, suddenly now, with this virus type of a situation, we're all looking back as to how we are going to be able to use our distance education system. Obviously, with the availability of the computers, the internet systems, we will be doing much better than what we did as a one-way broadcast. This will be a fully interactive kind of a distance education will be possible for us to proceed. And this capability today does exist. Next. The satellite communication system is being utilized as part of the telemedicine system. And again, recently when I looked at some of the things, I found out that even for this virus related things, again, telemedicine has become really a very, very important aspect. Next one. We are using this our satellite communication systems for our defense also. Next. Now that's a satellite GSAT-6. Look at the big antenna that we were able to use it. With this, it is possible now to use a mobile phone being able to directly communicate using our mobile phone-sized telephone instrument to work with this kind of a satellite. Next one. This is a radar imaging satellite so that we can take the images in the daytime, nighttime. We can take the images through the cloud cover also. Next. This is a hyperspectral imaging mission that was launched the 43rd and along with that our satellite, we launched 30 foreign satellites. In one of the earlier launch, we had launched 104 satellites also. This has become now a very interesting kind of a mission for ISRO, that being able to launch the small satellites for some of the other countries. Next one. We have now completed our Indian region navigation satellite system, NAVIC, and it has results are getting very, very comparable to what we get out of GPS. Next. Space, when we think about it, it always attracts us, but at the same time, we know it's mysterious, dangerous, adventurous, risky. It's wonderful also. The real thing is it's adventurous and it's absolutely quiet there in space. Next one. There are dangers in space. We are familiar with comets, shooting stars, micrometeorites, meteor showers, meteors and asteroids. And these are natural objects. They not only appear in the sky, but some also enter in our atmosphere. Most of them vaporize or burn up. If the object is large enough and heavy, it can survive entry in the atmosphere and it can land on the Earth. Now, these objects can cause considerable damage. Satellites in the near Earth orbit constantly lose energy due to aerodynamic drag and friction. Their orbital heights keep on reducing and they finally enter in the atmosphere. Now, these objects can also pose a danger to the aircrafts and the space flight. Next one. When a satellite is launched, the lower stages, they fall off in the sea, but the last stage gets into the orbit and then it becomes a debris. And with so many satellites launches have been taken place so far, the space debris is growing. Next one. And there are natural space debris as well as man-made. The natural is basically the micrometeorites and the man-made are the defect satellites in orbit. Now these defect satellites, when they enter into the atmosphere, some of the things which they don't burn up, they're very, very large items of it, particularly what happened during the Skylab in 1979, or what happened when the Columbia entered into the atmosphere. The natural ones, we know. Next one, we know that a crater has been made. Next slide. This is a crater at Lonar that has been made by a meteor which struck, I think it is close to Amravati in Maharashtra. Next. This is the meteor strike that took place in Chelyabinsk in Russia on 15th February 2013. Next one. We got large amount of data from this telescope, the Hubble telescope. Today, the Hubble telescope is no longer functioning, but it is now followed up with our satellite. Next slide. The Astrosat. So this is the Indian satellite launched from the Sriharikota or the Satish Dhawan Space Center, and it is providing us a very large amount of data. Next one. That's the International Space Station. The International Space Station was supposed to have been closed around 2018, 2019 or so. Then they said that, okay, it might go on up to 2021. Now they're saying that they will keep on using it at least till 2027 or so. And from now onwards, it is going to be utilized as a facility available for commercial exploitation also. Recently, USA was able to launch their own astronauts on their own launch vehicle after 2011. I think this is the first time they were able to do it on their own rockets. Otherwise, they were launching their astronauts using the Russian launch vehicle. Next one. In 1968, Buckminster Fuller, a very well-known architect, had written a book, Operating Manual for Spaceship Earth. It was quite a thought-provoking book. He had indicated that we are traveling in space at a speed of about 30 kilometers per second in orbit around the sun, and each one of us should consider ourselves as an astronaut as we are traveling in space. An astronaut is trained to live, survive on limited resources. He had wanted every person on the earth to understand that and adopt that as a living practice. On the earth, we have to live within available resources. So we do not get anything from outside except sunlight and some meteorites. Next one. Early in the last decade, when our former President APJ Abdul Kalam was asked about his age, he had indicated that he was in 73rd orbit around the sun. He was addressing students at Ayuka Auditorium in Pune. I think this is the kind of an attitude that which we must really have, that we are in orbit around the sun. We are all astronauts. Next one. We are always reminded about what Rakesh Sharma said about giving the answer to Mrs. Gandhi when the question was asked, वहां से भारत कैसा दिखता है? तो राकेश शर्मा ने बताया था, सारे जहां से अच्छा. And that really became very, very interesting kind of a thing, that an Indian astronaut was launched on a Russian vehicle. Since that time, when we're looking at it, so when we can have that kind of a thing going on with our own launch vehicle, our own space capsule also. Next one. That's Kalpana Chawla in one of the flights. Next one. That's Sunita Williams in the International Space Station. Now, living in space requires, next slide please, people to be able to do all the medical help themselves. They have to do all their testing continuously regarding the blood or whatever else they are going to use. Next one. And yes, they have to do the exercises also in space if you have to keep up with your normal tone of the muscles. Next one. Astronauts do require food. And this particular item, the food which was made for the astronauts, really became very, very interesting thing for almost every museum. Whenever you go to in USA somewhere, you will be able to find this really fast selling items at any of their gift shops. But basically, this is the kind of a food that was actually required to be made for the astronauts, so that there is zero bacteria and it is very easy to digest and can be reconstituted using only water. Next one. In the future, this is growing the vegetables on the International Space Station. It is happening. They were able to do it, and in the future, maybe we'll be able to do many more things like this. Next. When Rakesh Sharma had to go to space for, a question had been asked as to what kind of a food he's going to get. Is he going to eat the Russian food or something Indian? And then the food for Rakesh Sharma was developed at the Defense Food Research Laboratory in Mysore. Same laboratory delivered food for ISRO payload scientists. The same laboratory was also delivering food for our Antarctica missions. Technology has been then transferred to many industries, and the food included chicken tikka, chicken biryani, yogurt, upma, suji halwa. Next one. The food that was actually made, the technology that was transferred, has been utilized as for the prepared foods, which could be then provided in case of a disaster-related thing. This was definitely done for when there was a problem in Chennai, as well as it is used for our Antarctica expeditions. Next one. We can manufacture certain things in space, particularly where it is zero gravity, there is no convection. So newer alloys can be made there, better growth of large crystals can be carried out, better synthesis of long chain molecules for pharmaceutical medicines can be done, 3D printing can be carried out. Next one. Optical fiber can be manufactured in space, and this has been carried out using the International Space Station. Such fibers will definitely have a much better properties compared to the one that we are making on the ground. The space exploration can be also very profitable in the future. We're looking at what kind of things can be made in space, who we can use in space, what can be brought back also. So there are certain metals which we can get in space, which can utilize there, certain things we can bring back also. Particularly gold, iridium, silver, osmium, palladium, platinum, rhenium, rhodium, ruthenium, and tungsten. These are the ones that can be actually brought back to the Earth. Next one. The most valuable material necessary for mankind in space is water. When a space habitat is established on Moon, Mars, or other planets, water will be required to be provided for the people. And thus, quest for water is very, very important. In our planning for human presence in space, we need to carry water from the Earth. Can we get it in sufficient quantity in space and use it in the space habitat? That's the question that we are looking at it. Next. Enceladus, moon of the Saturn, the image actually shows that there are plumes of water which are coming out. Same way, Europa, the moon of Jupiter, also does show that water presence is there. Next one, please. Next one. Next one. The Curiosity rover on Mars, they had been able to drill a hole in that particular rock that you can see there. The next one. And once this has been possible to be done, they were also able to carry out the next level, and that is to find out whether there is organic material, and it has been found that the organic compounds were found on Mars. Next one. Stephen Hawking had said that we have given our planet the disastrous gift of climate change. When we have reached similar crisis, there has usually been somewhere else to colonize, but there is no new world, no utopia around and the corner. We're running out of space, and the only place to go are the other worlds. Stephen Hawking was very, very clear that we will need to colonize space. We will need to go out to some different planets, maybe some different locations, because according to him, in about 100, 150 years, the air on the Earth will be so polluted that it will not be possible for us to live on the Earth. Now, many people are still very skeptical about the climate change and its effects, but yes, that's the kind of a worry that he had. Next one. Although the chance of a disaster to planet Earth in a given year may be quite low, it adds up over time and becomes a near certainty in the next 1,000 or 10,000 years. And what he was saying was that, okay, if this is something which is going to happen, then we should be prepared, and we have to start looking at it for our future out in the space somewhere. And in the next 100 years or so, we may have to do that. Next one. We train our people for the zero gravity using a commercial plane also. Next one. Next one. Stephen Hawking wanted to actually experience the zero. Go back a bit. Go back. Wanted to go through the zero gravity experience. I think there is somebody's microphone is open. Please check. Okay. The Stephen Hawking wanted to go to the space, but at least he was able to go through this zero-G experiment. In the another slide, you can see Richard Branson, as well as the student that I talked about, Mr. Modi. Next one. This is Colonel John Glenn, the first American person to orbit the Earth. At the age of 78, he again went back to space. And I'm quite certain that we don't have to worry about a person has to be extremely young, very fit kind of a person. But yes, he was able to go. And in the future, space tourism also will become a possibility. Next one, please. There are anti-satellite weapons which were developed by USA. Next one, by China. Next slide. And next slide, by India. That's our mission Shakti. Next one, please. The future vehicles that we are looking at it, there are many futuristic programs for access to space. Conceptual and experimental hypersonic planes are being tried out. Elon Musk's Falcon 9, Falcon Heavy, and Richard Branson's Virgin Atlantic. Virgin Galactic. Next, please. That's our GSLV Mark III, which we have used for the launching of Chandrayaan 2, as well as for very large, heavy satellites. Next one. This is our trial for the reusable launch vehicle technology demonstrator. It will go off like a rocket, but will come back to land as a plane. Next one, please. Next one. There are some of the concepts that we can launch these rockets using large planes, and then one can actually have a satellite being launched using a smaller launch vehicle. Next one. That's a spaceship developed by Richard Branson. Next one. That's a Blue Origin. That's a vehicle that is being developed, if I'm not mistaken, by the investment from Mr. Bezos of Amazon. Next one. I had heard about the SpaceX launch vehicle, and I had the opportunity to go and visit and see the launch vehicle actually being made. This is a very, very interesting launch vehicle, particularly because it has the first stage which can actually come back to land safely, not just simply fall in the sea. The next one, that's the one that you can see it's actually coming down and actually landing at a designated spot. Next one. It's a heavy launch vehicle of the SpaceX. Next one. And that's the recently developed, the Dragon capsule. It carried the astronauts to the International Space Station. Next one. That's how the capsule had actually docked with the International Space Station. Next one. The capsule is very, very interesting interior earlier compared to what I had seen earlier things for the space shuttle orbiter, or the one for the lunar module also. Everything now, all the instruments, all the data is being shown using the computers on the screens. And most of the things people are using in this equipment, everybody is using basically the touch screen. Very interesting concept for the actual capsule. Next one. And that is what we are going to do, that for our Gaganyaan, again for 3 astronauts, the crew module, the orbital module, and we'll be launching using the GSLV Mark III for this particular vehicle. The next one. Our first mission will have a duration up to 7 days, and whatever systems as necessary, we have tested it. The next one. That's the actual mock-up of the capsule that we saw last year in Bangalore. Next one. We have tested this particular system for the actually recovery of the crew module, what you see there. Next one. As it was recovered in the sea. Next one. And we've taken the test of the crew escape system. After this thing now, astronauts have been chosen. They were undergoing training, but I think the training has been now halted because of the virus situation. Let's see when it will start up again. Next one. Nelson Mandela had said, "It always seems impossible until it is done." Now, this is very true in the case of space technology. Dr. Vikram Sarabhai and Professor Satish Dhawan had the confidence that we could excel in the use of the space technology and its applications for the benefit of the common persons in our country. Powered by their leadership, we had worked hard to realize their vision. And I have confidence that we will continue on the path shown by them. Next one. Robert Frost had said, "I shall be telling this with a sigh. somewhere ages and ages hence, two roads diverged in the wood. And I took the one less traveled by, and that has made all the difference. Next one. We see all these stars around us. Next one. Thank you very much.
Okay. I will stop sharing this presentation. Then we will have some question answer.
Yes, correct.
I am sure there will be a lot of students who must have got interest created after listening Professor Kale.
Yes,
I myself came to know about so many new things in spite of working in ISRO for 39 years. Yes. Akshay, there will be a lot of questions in the chat box also. One by one, you will have to control that, and we will have some questions one by one.
I'm going through the chat box.
Yeah. I will open the chat box.
Participants, if you have any question, put it in the chat box.
Kale Saab can see the chat box, the questions.
I'm not able to see it. I'm just 1 minute.
At the bottom, there is a chat box. Click.
Yeah, at the bottom,
just now
there is
click.
chat.
Okay.
Yeah.
Okay.
Uh,
There is a question from Priyanka Javale to everyone. So let her ask the question. Let us see.
Yes, am I audible, sir?
yes.
Yes, you are audible.
Yeah, thank you very much, sir, for a wonderful session.
ahead.
I wanted to know about the from the legal side, as new amendments are suggested in a new space bill. There are provisions which says that new startups in a space sector, if the Indian startups, they are going to have they are not excluded from GST, whereas to attract outside investment in Indian space sector, the GST is waived to the outsiders. So do you think this legal matters are hurdle for the indigenous growth in our sector? Your opinion?
I don't think so. I think if everybody is doing their calculations properly, they can do the calculations properly and they can still be competitive for this kind of thing. I think what is important is that what I had been studying, what I had earlier also talked about once in a while, is that the Indian industry has to really get together as to how they will be able to share the test facilities, join together, and they're then in a position to actually reduce their cost. But the specific tax related kind of a question, at least I'm not competent to really answer that kind of thing. Thank you for your questions.
Thank you, sir.
Another question by Tanvi.
Good evening, sir. Thank you for such a wonderful session. My question is, there was an image in which some people were observing the moon rock. So who brought the moon rock?
This happened in 1969. Neil Armstrong and Buzz Aldrin, they had landed on the moon. They brought back the moon rocks. Some of the moon rocks then USA had sent on exhibition to various locations all around the earth at various locations. And Neil Armstrong and Buzz Aldrin, both, I think all the three of them, and Mike Collins also, they had visited India, and if I'm not mistaken, they visited the Tata Institute of Fundamental Research, as far as I remember. But I was not here in India at that particular time. I was at the Goddard Space Flight Center. So the moon rocks were brought back by Neil Armstrong and Buzz Aldrin.
Okay, thank you, sir.
Welcome.
Sir, can I have one question, sir?
Go ahead, please.
My name is Dr. Ashok Kumar Shukla. I'm professor in Bangalore in one of the engineering colleges, East Point College of Engineering Technology.
Okay.
One question is bothering in my mind. Of course, it is a wonderful research activity that is exploring the space and going to space and bringing the rocks and the specimens of other planets' soil. That is fundamentally okay. Now it is becoming a kind of commercial race to colonize Mars or Moon or other planets or like planets like Earth where life is possible. But it is at the exorbitant cost. Number one, man, it is a fundamental philosophical question, sir. Man has, number one, polluted his own planet, which is having plenty of oxygen and water and life material available for over the decades and centuries, which we have damaged in the last few, maybe one century after industrialization in the name of urbanization. A fraction of that cost can help cleaning our planet itself and make it a wonderful heaven to live in. This is a fundamental question. I'm not getting an answer. Scientists are, everybody is talking about going to space, colonizing the other planets and spoil there also and search another planet. Where this race will end? I want your expert answer, sir, to this.
Okay.
I'm very kindful to you, sir.
I must say only one thing, that when this virus situation came up, okay, and the lockdown occurred. Now, during this lockdown, what did we learn? We actually learned one important thing, and that is once the vehicular traffic had been stopped, our air quality definitely improved here in Pune. It had improved in Delhi. It had improved in Mumbai. It had
Yes, sir,
improved in
everywhere.
Ahmedabad,
Yes,
Bangalore. So when we are looking at the damage, we can actually stop the damage not by spending the money. Actually, by not spending the money, we should be able to do that kind of thing. Okay? So that's what is actually happening. Now, going to other planets, that was the kind of a thing that people have been talking about. People have always the dreams of space tourism. Jules Verne even wrote about the trip to the moon even before any rocket was even invented. So we have to have this kind of an adventurous spirit. When we want to go out and do something out in space, fine. When we talk about the cost, where is the cost going? It is going back to the people, right? When we say that, okay, we are going to make a rocket, today when we make the rocket, 70% of our work actually gets done in the Indian industry, in our own country kind of a thing. Now, if we were importing those things, then we can say the cost is such that we are sending the money outside of our country to some other country. But now when it happens, particularly for any country which is ready to do it, they will be able to do it by spending the money in their own country. The money goes back only to the people, okay? And as far as the spoiling the other planets or other places are concerned, at least we are taking full care that, okay, whenever we launch certain things, we are completely sterilizing. We are not going to damage that particular place. We try to take as many precautions as possible. For example, if we are going to go towards, say, Mars, we should not be, or the moon also, we should not be carrying solid rockets which have got aluminum or some other material in it. We should be using the liquid fuel rockets. That's the way people have been now working on it. And we will keep on working in that particular direction. But the real issue that is going to come up is what happens when space tourism takes place. The tourism related things, which when it comes up, yes, the damage has occurred in Antarctica, damage has occurred near Everest, in all other places also. So if we learn not to do it, just as we learned during the lockdown period, I'm quite certain that we will be able to manage those things. Thank you for your question.
Thank you. Thank you very much, sir. It is a good answer you have given. I'm grateful to you, sir. Professor Pramod Kale.
Yeah, one question is from Mr. Gupta, Patricia Visha Gupta. Can you ask your question?
Yes, sir. Sir, good evening. Sir, I want to ask the thing that after Neil Armstrong, there have been so many space missions and so many have been successful.
Mhm.
But why don't anyone take initiatives like these are very rare to send humans to land on moon or any other planets?
Well, after the Apollo, if I'm not mistaken, 17, The next Apollo mission was cancelled, and it was used as a Apollo Soyuz test flight, test project, Apollo Soyuz test, ASTP, and that was carried out in 1975. After that, there has not been any manned flight to the moon. And I've been reading that, okay, USA is planning something in 2023 to 2024 time period onwards. They might again think about going to the moon. One very interesting thing which I read recently, last year, was that, okay, when Neil Armstrong had gone to the moon, and one of the things that they remarked was that the dust on the moon, which came back along with their shoes into the capsule, the lunar module, what they had, they actually were able to say that, okay, it has a particular kind of a smell. Now, in those days, there was no sensors available which could have detected the smell. So definitely there is a value for a human being or an astronaut to be sent out. People keep on always asking, why are we sending people there? Why can't we do everything robotically? There are many things that human beings can still do. And that's why in the International Space Station, they're still continuing with the human presence. I think since 2006 or 2007 onwards, it has been continuously populated, the International Space Station. There are such missions which are going on, but going to the moon, etc., we have to think as to where to not only go there, but also get back the person. When this Mars 1, that mission was announced, a large number of people suddenly started registering for that thing, even though it was announced that, yes, it's a one-way mission. You're not going to come back. Now, if you're prepared to do that kind of a thing, there will be many such missions which will come up in the future. But there has got to be the mission for a specific purpose. Once the purpose is known, I think a proper mission can be planned. Thank you for your question.
So another thing that is it very difficult to land a rocket like that happened
Yes.
on moon?
Right. Yeah, it is difficult to land that kind of thing because finally we require the final guidance related things. It is difficult. There have been earlier for the surveyor or some of the other missions, there were failures. Neil Armstrong also in his book, what I read about the Apollo 11 book also, they could have actually collided. But since a human pilot was there, he was able to see that particular rock and he was able to steer around that one. And that's how they were able to successfully land. It was a much larger vehicle and yes, they were able to land properly. It is difficult, certainly.
Thank you, sir.
Okay, Dilima Sharma is there. She has want to ask one question. Dilina Sharma, please.
Good evening, sir.
Good
This
evening.
is Selina from Chittorgarh, Rajasthan. Sir, I have a question that as a student, I'm a student of class 10th and this year I am going to appear in board exams. So how can I contribute myself to space scientist science and how, as a student, what role can I play?
Okay. I think the first thing that you need to do is that you have to choose your subject that you really want to study, whether it is connected with space, means astronomy, whether you want to actually get into that kind of studies or you want to study a particular subject like chemistry or mechanical engineering, material science, physics, any one of the subject. Choose whatever you really want to do and you will be able to contribute to space. Let me tell you one thing that for the space related things, we require people from every single branch, including whether it is arts, commerce, law, whether it's connected with taxation, as the question was just now asked to me. So certainly, yes, you will be in a position to actually contribute by doing your studies in any specific subject, but you must have one goal, and that is you must have interest in space and space related subjects. Then you can contribute.
In which branch there is most scope?
It's basically engineering, certainly. Right now, at least.
Thank you, sir.
Okay.
One of the students I had met, she had talked with me about designing the space habitat related things. There are architects who are also really thinking in that direction. And I have seen this kind of change that is coming up compared to what was designed during the 1960s or so for the Mercury or Gemini or Apollo mission, the complete thing changed when it came to the space station related things or the space shuttle orbiter. The Dragon capsule has completely changed. So even architects, definitely, they can contribute.
Okay. Yeah, Mr. Gaurav is there.
Hello, sir.
Yeah. Go ahead.
Good evening, sir.
Good evening.
My name is Gaurav Ghosh, and I'm from Calcutta. I have a small question related to abrasive material, which is being used in space shuttles to decrease heating effect. As this small material topic which I actually touched during my class 11-12 project.
Yep.
I didn't go much of a depth, but can you please enlighten us about how you improvise this kind of materials and how the heat reduction is done?
Yeah. Okay. Supposing if you have a very simple experiment in your hand, let us say that you wet your hand and then try to catch another heated object. Okay. What will happen is that the water will evaporate. The water will take away the heat when it evaporates and goes away, so that that particular heat will then not come to your hand. The same kind of a thing happens when we use ablative material. It is the ablative material which carries away the heat and does not allow that heat to go inside. We use it on our heat shields. We use it for the space shuttle. For there they had actually used the quartz related material. That material was developed very specifically. So question is as to where the heat goes. If you can carry away the heat away from the body, that's the one that is really important. So the ablative materials are used in that way. We use as a thermal paint, it is called. That can be also used, or there are materials which will actually decompose and they carry away the energy and the heat and not allow it inside object to get heated up.
Okay.
Thank you, sir. So another small question is there. Like, it is a very childish question for me. What kind of challenges do we face while making a rocket on our own?
The first and most important thing is to develop the propellant. Nobody will share the knowledge regarding as to how to make the propellant. And it's a very, very, what should I say, risky job also. When we had started making the propellants in Trivandrum, I think in the initial period, we used to not be able to actually burn it, but it used to explode. So we used to have maximum number of explosions when we were actually testing, because I was in charge of the testing of some of these small rockets which are being developed. We have to be able to make certain that it actually burns and not explode. So that's the real big challenge whenever we are developing any rocket related things.
Okay, sir. Thank you very much, sir.
Thank you.
Yeah, Akshay, it seems there are some questions on YouTube. Can you get those questions? Akshay, please.
Unmute yourself, Akshay. Please unmute yourself.
Now I'm audible.
Yes.
Yes.
There's a question from Ulkesh Desai. So what are your thoughts on what ISRO should be focusing in the coming decades in terms of utilization of space-based technology for the benefit of the society?
Okay. I think the most important thing right now is going to be as to how we will be able to utilize our communication systems, particularly the communication satellites, and actually contribute towards the education. Because this particular virus situation has actually shown us that we will definitely need our distance education systems, both for the teaching, for learning, for managing, as well as for examinations also. So I think that is going to be the real challenging contribution that the space missions that we will be able to make using the communication satellites and the communication systems for all the different types of education.
Okay. There's another question. What is the weight of a space suit?
What is the
weight of the space suit?
I think weight is because the water has been removed from it, it becomes very, very lightweight. But again, the water has to be added in that one. So the weight is just like our normal food. Space food is not anything different. It is just only that it is preserved properly, it can be reconstituted, and it can be stored properly for years together. Other than that, the weight is the same, like normal food.
There's a question from Arup Dasgupta. Why can't we use the ISS as a starting point for human in space program?
A human in space program, we need to first of all get out from the Earth and get to that place. So if you were thinking about using ISS, but even to get up to the ISS, we require our own human in space program. ISS, as an International Space Station, when the treaty was being signed, somewhere along the line, India did not join with the International Space Station related things. So today, I don't think that is possible because the ISS is going to be also shut down by 2027 or so. So in the next 7 years, I think they're going to shut down. Whether a similar thing will continue, because right now, the ISS itself is quite aging and the technology has become quite old. It's difficult to maintain the International Space Station. There were two stations which were being planned. One was going into the equatorial orbit, another was going into the polar orbit. The polar space station was cancelled because the total expenditure, but I think real expenditure came from USA, USSR, Japan, and European Space Agency also. And I don't think that many other countries actually participated in building it up.
Yeah, Akshay, a few more questions.
Yes.
2 or 3 questions.
Yes,
I think it's getting quite late, so just see how many people.
Take especially from students some questions.
Yes, certainly, no problems at all.
So there's a question. So we are surrounded with thousands of satellites. How the space agency manages it while launching new satellites? How they manage newer satellite paths so that no collision will happen?
We keep on continuously tracking all the satellites. Once we know their orbits, we can predict where they can be. So we can constantly keep on doing that kind of calculations all the time. And every time when we launch a satellite, we have to have that calculation available such that collisions do not take place. For tracking the existing satellites, there are radars which are being used. Initially, such radars were available only in USA. Now we also have a multiple object tracking radar in Sriharikota or the Satish Dhawan Space Center. We can use that radar system for tracking. There are optical trackings also using the telescopes, which we can look at it. And this kind of work constantly keeps on happening, which is silently everybody is doing it. And certainly it is difficult to keep a track of all these satellites. Like when we launched the mission with 104 satellites coming out of the one vehicle itself, we were all worried that they can collide. Now we had this kind of worry even for our communication satellites also, because the satellites are costly, the services are very, very costly, and we could damage a good satellite. And so therefore we carry insurance also for that. This is a continuously working system, and we have to have that kind of working system all the time available.
Okay, so that's it. Yes, it's done.
Okay.
If there is no other question now, we will stop it here. Already we have become quite late. Let us thank Kale Saab for giving a very nice and interesting lecture. And it was very knowledgeable. All of us are benefited out of that, this lecture. And thanks for sparing his time. I request Ashish Soni to propose a formal vote of thanks. But I don't know, sir, how to give a memento to you online. So it is due, and some other time we will
Okay,
give
fine.
you, sir. Thank you.
Sure.
Sir, I request everyone to give full hands a big round of applause at my
Yes.
Yeah. Yeah. Thank you, Mathur, sir. Today's guest and eminent speaker, Sri Mathur, GC Jain, Sri VK Jain, Sri Anand Pathak, DES, SERF members, so everyone. I am honored and lucky to have the opportunity to give vote of thanks on a special day, as today is 101st birthday of Dr. Vikram Sarabhai, founder of Space Application Center Ahmedabad and Vikram Sarabhai Space Center Thiruvananthapuram. And today we had with us Professor Kale, who served as director at both centers. I extend a very vote of thanks to Kale sir for accepting our invitation and spared time from his busy schedule to grace today's occasion. A big thank you for the remarkable speech on space, our future. Sir, you had given excellent message from Aryabhat, Rohini to Mars mission, Chandrayaan 2, Gaganyaan, DTH, tele-education, telemedicine, HISIS mission, Navik, danger in space, EBRIS, Astrosat, optical fiber manufacturing, mining in space, space colonization of us by your great words, and especially every person on the earth is an astronaut. Thank you for your very provoking and interesting speech. We are very happy to see nostalgic pictures of seniors and respected scientists. Really made our path very easy, sir. I'm thankful to organizers, Indian space industry exhibitors, and Gyan Sikra Ahmedabad for organizing today's function. I'm thankful to all the Space Society of Mechanical Engineers Ahmedabad, Engineering Society Ahmedabad chapter, Swiss Education Research Foundation Ahmedabad. I'm also thankful to Mr. Akshay Dhotre of Indie Carbon Composite Mumbai for providing support for Zoom and making technical arrangements for YouTube live telecast. I'm also thankful to Mr. Sanjay Saxena, our media partner and chief editor, Sunrise India Samachar, New Delhi. I'm specifically thank the people who have backbone of this event, Sri A.C. Mathur, Sri GC Jain and Sri VK Jain. Without them, this program cannot be imagined. Last but not the least, special thanks to all participants attending today's webinar and make it very successful. I would like to end my speech with following one. उजाला सदा आपके, I repeat, सुप्रभात का उजाला सदा आपको, हर दिन का एक एक पल आपके लिए खास हो, दुआ निकलती है दिल से आपके लिए, दुआ निकलती है आपसे आपके लिए, गिरो खुशियों का जाना सदैव आपके पास हो. धन्यवाद. Thank you very much, sir. Thank you very much. Mathur, sir.
Yeah, thank you very much, Ashish. I am sorry that we could not allow more participants today because of our technical limitations in the Zoom. There were many members who were waiting. And YouTube, I could see in between there were more than 200. So
Right,
Kale Saab is very, very popular among ISRO community, at least. Whenever he visits Ahmedabad, and people like to meet him and listen to him, and for his talks. And of course, I also got an opportunity to work directly under that MCA project in Set 1 in Hassan, Karnataka district. He was the project director. I used to come from Bangalore, and I was posted at MCF Hassan's site. So thank you very much, sir, once again for sparing your time and giving a very
pleasure for me.
talk. Thank you, sir.
It was certainly a pleasure for me.
Yeah. Okay. Those we could not entertain all the questions also, please write to me through email. and I will forward to Kale Sahab and get a reply for that. Thank you very much, sir.
Thank you.
Thank you very much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Sir.
Very good. Good lecture.
Thank you, sir.
Thank you, sir.
Sir, we are waiting for next
Wonderful
question.
Thank you very much, sir.
Thank you, sir.